And okay, and I just started the recording, but what we are doing today is we're looking at polyatomic ions. And yeah, and we were just talking about how you want to open this page in your own realm. So this is linked from week 7 calendar on Friday. And if I could, I would hand you this printed on a piece of paper. And actually, when COVID started, I just pulled this piece of paper from the real physical classroom because I use it all the time. And in our classroom, our periodic table has on the back this page. And so among other things, you can use all of this through the end of the last final. There's no reason to memorize any of this. Part 2, you're going to start seeing with some repetition some of this stuff, but I'm getting ahead of myself. Let's just open that and have that on your screen so that you can use it. But today, I'm just going to get you into how to read it, what is going on. Is it okay if I head out and start on more notes? That's fine. Yeah, you're keeping yourself up with all the things, and good luck. You asked your questions, which is perfect. Feel free to drop in if you have more. Yeah, and good luck. Yeah, great. Okay. Yes, you too. Thank you. Have a good day. Cool. All right. Off we go. So we are going to do today's lesson on our Zoom call. And okay, so today we're looking at polyatomic ions. And okay, and we opened our page, PDF, and I am going to try to get you credit right here, right now. So I'm going to say some things and then ask you some questions and go from there. Okay, so on that page, you're going to see a lot of little circles. Seeing circles, lots of little circles. All of the circles have a few kind of characteristics. Usually in class, I hand you that page and say, what do you notice? And so you can start to look at it on your PDF, and you will start to notice things like there's kind of, here's the anatomy of the circles on this page. We have a drawing in the middle, some sort of drawing. We have a box up on this side. We've got a name down here, and then a formula under that. Okay. And those are kind of the 4, just like your periodic table. When we first started with your periodic table, we were looking at the symbol and the number of protons and the name and the mass of each block on your table. Here on the other side, each of these circles has a few things in it also. So in the middle, you've got a drawing or a picture of that thing. And that thing, that's not a very specific set of words. These are all polyatomic ions. So they're all ions, just like the monatomic ions we've been looking at before are also ions. Good morning and welcome. Okay, so today is Friday of week 7. I'm just going to do my whole spiel again. Glad that you are here. Yeah, that's it. I'm glad you made it and welcome. And I hope you're having a nice morning. It's like somewhat sunny out, which is like awesome. Yeah, and we're getting towards the end of quarter 3. I think I just said 4, but I meant 3. Yeah, Friday of week 7. If you're working on getting in late things turned in. They're all due by Wednesday of this upcoming week. So you've got another weekend, but they're all due March 17th. And yeah, we're getting close to the end. So next week is a full week, and then the week after that is finals, and that's it for the whole quarter. It is a Friday, however, we are not doing a quiz for a bunch of random reasons that we don't have to get into, but we're going to do a little chunk of content today, and then more next week. And our goal for right here, right now, is to offer, if you would like to earn credit during your Zoom call, you are welcome to do that. I'll talk you through some things. I'll ask some questions. You can answer verbally or in chat, and we can get you guys credit for today's stuff on this Zoom call. If you open your calendar for today, there's a PDF. There we go. This PDF of polyatomic ions. Yours will be in color. This is like a printout from the real building, and it's not in color, and that's cool. But the one on your computer is in color. Okay, so if you want to open that, that will be handy. And off we go. So we're talking a little bit about, like, and I should say also, if you have any questions about anything, feel free to jump in verbally or in chat or anything, and that's awesome. I'm going to keep driving this bus forward, but let me know if there's anywhere else that you'd like to go as well. Cool. Okay. So we're talking a little bit about kind of the anatomy of each of these things. And then I realized that I didn't even tell you what we're looking at yet. Like, we wrote this name down, but we haven't like looked into it. So we're looking at polyatomic. And we were just saying, usually I hand you this page and then say, what do you notice? And you say, well, it looks weird. I haven't seen this before. All of these little circle thingies. I see some lines, I see some circles, I see some words in little boxes. So you've got the name of each thing down here. You've got the formula over here. And it's kind of like on your periodic table, the very first thing that we did was talk about how we've got the symbol and the name and the number of protons and the atomic mass in each box on our table. Same idea here. So here we've got little circles. Cool. And each little circle has some information. These are all ions. They all have charge, just like everything this week has charge. The charges are in these little boxes up in the top corner. So this is the charge. And kind of in the middle is the drawing. Underneath is the name. And then they've got this labeled for you. The formula has which atoms are included and their charge. Okay. And we just kind of wrote that same stuff. That top corner is the charge, the middle is the drawing, underneath is the name, and at the very bottom is the formula for each of our polyatomic ions. But what does this even mean? Polyatomic. Well, this looks familiar. That looks like atom. They're all ions. They're all charged particles. And this poly word, or like prefix, is kind of like your math realm. Poly means many. So these ions, these charged particles, have many atoms. And that kind of makes sense because in your drawings, you've got lots of atoms. And in your formulas, you've also got lots of atoms. So this drawing has 1, 2, 3, 4 atoms, 1 carbon and 3 oxygens. Your formula also has lots of atoms. Your formula has 1 carbon and 3 oxygens. This has a charge of -2. This has a charge of -2. We could do it for this one also. Acetate has 2 carbons, 2 oxygens, 3 hydrogens. Same in its formula, 2 carbons, 2 oxygens, 3 hydrogens. Charge of -1, charge of -1. And that's actually most of it for today, is just kind of starting to get familiar with this page. There's a really great chance you've never seen this before. When we're in the building, it's like literally on the back of your periodic table. So like the whole quarter, you're, accidentally pulling out the side first and being like, oh, this is the side I actually want now. But today's the day that we turn that page over and start looking at the polyatomic ions. And we were just talking about how there's tons of ways to get credit for today. One is to answer some questions here. The other is I've got a Kahoot linked, and you can do this with a friend or you can do it on your own. Just answer some questions to get a feel for your polyatomic ions. So if we want to do this today, let's say find an ion with a -1 charge and either say or type into chat. And we'll say welcome back. And in just a moment, welcome back. I'm glad you have joined us again. Feel free to jump in with any questions. We were just getting to the point of asking y'all some questions that you could then answer on the Zoom call to get credit for today. Today's a shorter lesson, which is like nice. It's a Friday. Also, this is kind of designed so if you have extra questions, you didn't miss much, right? Agree. Yep. Yes, this is a great time to join back up. Yeah. Really, the only ideas today are kind of how, and I'm glad you're back, how to read this table. So this is linked in this week's calendar on Friday. It's going to say polyatomic ion PDF. And if you click that link open, it'll give you this table in color. And you've got a drawing in the middle. You've got a charge on this top corner, names underneath, formulas under the name. And today's whole goal is just kind of getting accustomed to reading these many atom ions. So your first question is find an ion with a charge of -1 and either type it into chat or say it out loud, and I'll get a paper roll and we can get you guys some credit right here, right now. And if you're like, I didn't understand the question, or I don't know what I'm doing, or if you want to see the first one as an example, that's awesome. I'm just setting up my stuff on my side. I don't understand the question. Great. I am glad you asked. So the question is, find an ion. Here, find a polyatomic ion that has a charge of -1. And then find the name of that ion and either say it or type it into the chat box. Yes. Okay, I'm glad you asked the question. And we'll use these same instructions, though I'm going to change up what you're looking for. But so each time I'll say find a polyatomic ion that something. So in our first example has a charge of -1, but maybe I'll say something else next time. So but let's do this one together. Find a polyatomic ion that has a charge of -1. Okay, that's your first step. So find your page, and what we're looking for is any ion that has a charge of -1 is what we're looking for. Okay, so but we have to remember, okay, we're looking for charge of -1. So there's a lot of information here. We've got the drawing in the middle, the name underneath, the formula under the name, and the charge is that thing up here. So that's where we're going to look for our charge. Okay. So we want to look for the charge in that little box in the corner. And our question is a charge of -1. So actually, a lot of these would answer that question. We've got acetate, has a charge of -1. Oops, although I did that backwards. Sorry, we should look for the charge first. So this one has a charge of -2. We want -1, so not this one. But this one has a charge of -1. We could use that. This one has a charge of -1. We could use that. This one has a charge of -1. On our next row, this is a charge of -2. There you go, exactly, just like that. Nikola's saying cyanide, yes, that has a charge of -1. And it's here, so here's your charge of -1, and she found the name. The name is in this bubble underneath, and either say the name or put the name in the chat box. And everyone is invited to join. You are invited. Find any polyatomic ion that has a charge of -1 and find that name is step 2. And then write the name into the chat box or say the name out loud. And a lot of these count. So this one has a charge of -1. You could say or type that name. This one's got a charge of -2. We're looking for -1 because that's like this question. This one's -2, but maybe, you never know. I might say find a polyatomic ion with a charge of -2 next. But for right now, I want to see if I don't want to call you guys out, especially because I'm recording, but anything that has a charge of -1, and the charge is this top box up here. So find something with a charge of -1 and type the name into the chat box. And oh, I'm going to go quiet so that you know I'm asking a question. So our current question is find a polyatomic ion with a charge of -1 and either say the name or type it into the chat box. I'm going to move on because I'm going to get you as much credit as I can. Next question, find a polyatomic ion with a charge of -3. So the first one was -1. Your next one is find a polyatomic ion with a charge of -3. And do the same exact thing. Find the polyatomic ion, find its name, and type its name into the chat box. There you go, phosphate. Awesome. Any other takers? I'm going to give you your next one while you're at it. Next question, since we got that charge of -3. If you're jumping in and not sure what to do, let me know. It's hard to know on Zoom if y'all are like what you're working with, but if you communicate, I will happily join you where you are. Last one on this round, I'll throw you something different next. The charge of +1. There you go. You found it. There's only one on that table and you got it. Nice. Okay. I'm going to throw you some different types of questions, but you're going to do all of them exactly the same way. So your next question is, find a polyatomic ion with 3 that has 3 oxygen atoms. This one's a little different. In this one, you're going to look at the drawing, and inside here, you're looking for 3 oxygen atoms. Exactly. Hydrogen carbonate has 3 oxygen atoms. Nice. Find a polyatomic ion that has a sulfur atom. Oh, actually, no, yeah. Find one that has a sulfur atom. Sulfate. Great. You may even see sulfate on your food labels, on your shampoo labels. There's all sorts of stuff sulfate can bond to. It's very prolific in our world. Nice, and it's based on a sulfur atom. Cool. Find one that has a chlorine atom. Or, yeah, it has a... perchlorate, yes, perchlorate. And you may even, I'm not exactly sure how to phrase this question, but you've got perchlorate, which is totally correct. Kind of look around at the other stuff near chlorate, how, and just make some observations. There's nothing you have to answer here, but like, how are they related to each other? How are the words linked? And we'll give you another, but just do that observation. Here's your next question though. Find a name that ends in 8. They keep adding oxygen. Exactly. Exactly. This is, yes, you're right on it, Michaela. Yeah. Sulfate ends in 8, and you're right on it with that adding the oxygens. This is what I'm about to say is an AP level thing. It's not even like a regular chemistry level thing. But that sequence of names means exactly that. Like it means adding another oxygen each time. So we randomly defined something to be the 8 form. This ends in 8 is not even necessarily the most common form. Some of this is a little bit antiquated, but we chose some form to be the 8 form. And then as we go per whatever 8, we add another oxygen. The ite form removes an oxygen, and the hypoite form removes another oxygen. But don't worry about remembering that. But the point was, you found the pattern by looking at this page, which is cool. And let's go with it. Find a name that ends in ite. There you go. Chlorate. Yes. Perfect. So your chlorate form has 3 oxygens. Your chlorite form has 2 oxygens. Nice. Oh, and the other thing here, can you find, this is a trick question. So like, usually you're not supposed to say it's a trick question, but it's a trick question. Can you find anything on this page that ends in, so everything we've done the last few days with our single atom ions ends in "ide"? Is there anything on this page, our polyatomic page, that ends in "ide"? Oh my gosh, well, you're right. Cyanide and peroxide. Cool. Good. That you're right. And yeah, you're totally right. Great. Okay, well, you're right. I wonder why, because we usually think of ide as being a single atom thing, but it's not here. Huh, that's weird. You're right. Cyanide. You're totally right. Go with it. Yes. Found multiple that end in ide. I wonder if it's peroxide, like perchlorate is added an oxygen and peroxide has added an oxygen maybe to its single form, and hydroxide is, yeah, anyways, nicely done. Yes, there are some that end in ide. We did charge, we did picture, we did name. Let's do formula. Oh, here's how we'll do formula. I'm going to give you a formula and you write the name, and then next I'll give you a name and you write the formula. So what is the thing with a formula? So I'll give you a formula, and what is the name of the thing with that formula? Is it on the chart? Good question. Oh, it's been so long. Okay, bonus point for it's been too long. CO3, 2 negative. That's what I actually meant. Whew. That one's on the chart. There you go. Yes. Carbonate. Yeah. This one has the interesting attribute of being the carbonation in soda. That's a little picture of, you know, when you open a can of soda and it goes, psst, that's the carbonation in your soda. Cool. If I say, oh, if I give you a name, can you give me a formula? One that we haven't done a lot. Yeah, I'm gonna do this one. And so that's the name, and what is the formula? And then we're almost done because I think you're like getting this. Sure. I can't write the numbers. You could say it. That would be another option, but you don't have to.
I'm not entirely sure how to say it. S, like the little 2, O, little 3, and then -2.
Great. Perfect. I won't ask you another one like that. Just because of technology and stuff like that. But you are correct. That's what that means. You don't have to do another one because that was correct. Cool. Great. I think you've got it. Because those are all of the ideas. You figured out the charge, figured out the picture, the name, the formula, and that's actually all for today. We'll take it further later, but the idea that these little things run around in little groups, They're kind of hard to break. I guess I haven't said that part yet, but like these circles are like a little pack, and you can break them apart, but it takes more like they're gonna stick together as much as they can, each little circle thingy. Yeah, nice work. Congratulations. That'll enter in as soon as I get this thing posted. But you're done for the weekend. You don't have to worry about the Kahoot. You already did the same exact like ideas and thoughts right here. So nicely done. Yeah, I like it. That was cool. You even left and came back and did today's stuff. And today was designed to be a little bit lighter because it's a Friday, but um, nice. Nice. Cool. Does anyone else want to earn credit here now? Right. I think we may call that a day and end a little early because we've had a few days that have ended a little late. And